All right, section 3.2, part 3. Okay, so now we have two examples. We just got done talking about discrete and continuous functions. So now we're going to do a couple examples involving both discrete and continuous functions. I'm sorry, discrete and continuous domains of functions. So here in example 4, we have a linear function equals y equals, they give us the equation 15.95x represents the cost y in dollars. So here we know y is the cost in dollars of buying X tickets. So X is the number of tickets. So this X here is the number of tickets. And this Y here is the cost of those tickets. So each customer can buy a maximum of 4 tickets. So that might be some interesting information, useful. Each customer can buy a maximum of 4 tickets. So we want to find the domain of the function. Okay, so we're asking ourselves, find the domain. Again, the domain is the input. Okay, the input in this case would be the X. Okay, so that input is the X. So the X is the number of tickets. So X tickets. So my input is the number of tickets. So we have to ask ourselves, okay, so how many tickets could they buy? Okay, so we could buy, let's see, 1 ticket. Let's say it was just me going. Okay, 2 tickets. 3 tickets, 4 tickets, 5 tickets. Oh, but wait a second. They say here each customer can buy a maximum of 4. So, well, we can't have 5 tickets. Okay. Okay. And then we always, what about negatives? Could I have a negative one? Well, a negative 1 ticket wouldn't make sense, but I could buy 0 tickets. Okay, so it looks like there's my domain, the numbers 0 through 4. Now, is the domain discrete or continuous? Explain. Well, this looks like it's just the number 0, 1, 2, 3, and 4. I have to ask myself, can I include these in-between numbers? So can I include the in-betweens? Meaning, can I buy 1.5 tickets? No. So that makes this one discrete. Well, why? Explain. You can't buy half a ticket. You can't buy a partial ticket. Okay, so I can't buy a partial ticket. I can only buy like 1, 2, 3, 4 tickets. Okay, I can't buy 1.5 or 3 1/4. Okay, so now we want to graph this function using the domain. So to graph this, I'm going to need input and output. So I'm going to create an input and output table. So input, output, I could have 0, 1, 2, 3, or 4. So if I buy 0 tickets, I would have over here, I'm going to do my work over here, y equals 15.95 times 0, which is 0. If I buy 1 ticket, we'd have 15.95 times 1. I'm using parentheses for multiplication. So that would be 1595. Okay. If I buy 2, it'd be 1595 times 2. Okay, I don't know that one, so I'm going to bring up a calculator here. So 1595 times 2, we get 3190. Money needs 2 decimal places, so 3190, not 31.9. Okay, so now what about 3? I'm just going to delete that 2, and let's make it a 3. So that would be 47.85. And then 4 tickets would be $63.80. Okay. So now it says, oh, I want to graph the function using the domain. So I'm going to graph each of these as an ordered pair. Okay, so let's see my x. I don't have any negatives, so I think I'm going to rewrite. Okay, I'm going to rewrite this. Oh, go thicker. And I'm going to put my axes right here. So this will be my x-axis, this will be my y. So let's ignore those ones in the middle. We're going to ignore those because we don't have any negatives. So since we don't have any negatives, we don't have to worry about it. Okay, so I need the point 0, 0. That's going to be right here. So here's a point 0, 0. I'm going to label the point. Okay, so now on my x's, I really only need to count by 1. So I'm going to go, okay, 1, 2, 1, 2, 3, 4. But on my y's, I probably don't want to count by 1 because I have to go all the way up to 63.80. So maybe 10s. 10, 20, 30, 40, 50, 60, and then we'll go 70. Okay. So then 1 would be 1590, so that'd be in between here. So we have 1 and 1590. Okay, it's kind of hard to see, so we'll just omit those for now. Okay, 2 and 3190, so 2, 3190. 3, 47, so it's 40, 50, so 47 is going to be right about there. And 4 is 6380. Okay. Oh, let's put a little lower, 63, closer to 60. Okay, and unlike this one function we did here was continuous, so we connected the dots. This one is not continuous, it is discrete. So my graph is just these 5 dots. You do not connect a discrete, so you do not connect the dots on a discrete domain. Okay. All right, next one. Okay, so here, example 5. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. So C is a function of B. So that tells me that since C is a function of B, C is my output, and B would be my input. Okay. So first of all, does the situation represent a linear function? Explain. So for every 1 bar I eat, I'm going to kind of create a table. If I eat 1 bar, I would consume 130 calories. If I eat 2 bars, that would be 2 of those. That would be 260. 3 bars would be 3 of them, 390, and so forth. If you notice here, my inputs go up by 1 each time. Up by 1, up by 1. My outputs go up by 130. So it has a constant rate of change, which means it's a linear function. Yes, it has a constant rate of change. Okay, so find the domain of the function. Is the domain discrete or continuous? Explain. Well, we kind of listed some domain values. I don't think we listed all of them. I mean, I could eat 4, 5. Could I keep eating these cereal bars for forever? Sure. I could eat like 10 of them if I wanted to. I'd probably be sick, but I could. Okay, I could also eat none of them and consume 0 calories. Okay, now could I eat half of a bar? Could I eat 0.5 of a bar? Sure, I could. Okay, what about 3.5 of them? Yep, I could eat 3.5 also. So my domain of this function, it looks like the least number of bars I could eat was 0. I'm going to do these on a number line. The least number of bars I could eat is 0. The most I could eat, well, there is no maximum. I could keep eating them forever. So we're going to start with 0. I could eat 0 bars, and I could eat bars all the way up here for forever. Okay, so it looks like my domain is all numbers bigger than 0. So all numbers from 0 on up. Okay, a better way of writing this, my x is bigger than or equal to 0. Well, since we're including all those in between points, that tells me it's continuous. Explain. I can eat a partial bar. Okay. Now graph the function using its domain. Okay. Well, we've already kind of got some points, so I'm going to go ahead and I'm going to do some of those points. I'm going to do what I did last time. This can't go negative, so we're just going to use this xy axis. And we can go 0, 1, 2, 3, 4. Sorry about the background noise. Okay. But it looks like my bars are going up by like, I think I'm going to count on this axis by like 100, 200, 300, so forth, 400. So if I eat 0 bars, I'm consuming 0 calories. If I eat 1, it would be 130. 2 would be 260. 3 would be 390. But I can include all the in-between, so I would connect the dots here and draw my arrow up like that for forever. Okay, so graph the function using this domain. So when it's continuous, you do connect the dots. So for a continuous domain, connect the dots. All right, So now your last bit of practice is to do these last your turn problems. Page 118, 28 through 42 even. Once you finish them all, you can go ahead and correct them with the answer key provided on Schoology.